Problem 20, we're again going to describe a solution set to an equation involving complex numbers. Now, later on when we talk about polar form of complex numbers, we'll have a better way of reasoning a priori with this equation and determining what the solution is without algebraically doing anything. But for now, we're going to start with the algebraic approach. Then we're going to graph our solution set, and then we're going to write a sentence that describes it. So, with that in mind, let me recall for you the formula for the inverse. So we know that ZZ bar is modulus Z squared. And so this tells us that if we divide both sides by modulus Z squared, we get that Z times Z bar over modulus Z squared is 1, and this is, of course, for Z not 0. But what this tells us then is that the formula for the inverse for non-zero Z's is Z bar over modulus Z squared. So, if we look at our equation, underlined in blue up there, our equation becomes, well, it started off as Z bar is Z inverse, but we can rewrite that as Z bar is Z bar over modulus Z squared. Now again, this equation does not make sense if Z is 0, so Z is non-zero here. So we can sort of divide both sides by Z bar if we wanted to. And when we do that, the Z bars are going to cancel on both sides. Scroll down a little bit here. And we get this expression. And this tells us that the modulus of Z squared is 1. But the modulus of Z is always a positive quantity. So this is the same as saying the modulus of Z is 1. So the solution set is a collection of all complex numbers such that modulus of Z is 1. And let's even unravel this a little bit further. The modulus, if we write Z, let me get rid of that for a second. If we write a general complex number as x plus iy, let's scroll down quite a bit now, then modulus of Z is 1 is saying the square root of x squared plus y squared is 1, which is saying x squared plus y squared is 1 by re-squaring, if you like. Now, x squared plus y squared is equal to 1 is, of course, the solution set. So we have two ways of expressing this. It's sort of the xy's such that x squared plus y squared is 1. That's one way. Or it's the z's such that modulus of Z is 1. That's another way. This is algebraic solutions. But we also know that x squared plus y squared is 1 describes the unit circle. So let me say these are algebraic descriptions. And then we also have a geometric description. We know how to graph the unit circle, and do it in blue, where, of course, this is the real axis, and this is the imaginary axis. So this is up here at I, this is 1, if we were to put in some ticks. So that's our geometric description, is the unit circle. And then, of course, we can, write a sentence. So the solution set to Z bar is Z inverse is the collection of complex numbers of distance 1 from the origin, which is the unit circle. we have our three ways of describing what the solution set is.